So we're going to be looking at transformers today, which you may have already come across before. But before that, we need to have a look at alternating current. Now, the voltage that is supplied to our houses in our plug sockets is an alternating voltage, which means that it has a graph that looks like this. Now, because the voltage supplied in an alternating current is constantly changing, it's very hard to apply a designated value for it. So what we've come up with is the RMS value for voltage, which stands for the root mean square. And the RMS voltage is given by the peak voltage in an alternating voltage supply divided by the square root of 2. Now, if I tell you that our household voltage has a peak voltage of 325 volts, if you divide 325 by root 2, you end up getting something around 230 volts, which is the characteristic voltage that you hear when you talk about how much voltage is applied to your house. And the same goes for current. The RMS current is also equal to the peak on a alternating current divided by the square root of 2. And this root 2 comes from the fact that we are averaging power. We know that P is equal to IV, so the mean power is equal to VRMS times IRMS, which is going to be equal to V peak times I peak over 2. So that's where this root 2 value comes from. So now let's look at how a transformer works and the reasons as to why we use them. Now here is what a transformer looks like. You have a primary coil, and this is where you supply AC current. You have this soft iron core, and you have a secondary coil, which is where you get your output voltage. Now how does a transformer work? Well, due to an alternating current in the primary coil, and because we know that any current induces a magnetic field, an alternating magnetic field will get induced. Now this alternating magnetic field will get conducted to the secondary coil via the soft iron core. Now when these magnetic fields are cut by the secondary coil, or more formally due to the rate of change in flux linkage, you're going to see that a voltage will be induced, and therefore you'll also get an induced current. So how does the output voltage across the secondary coil relate to the input alternating voltage? Well, we know the voltage across the primary coil is equal to NBA over T, where N is the number of turns, or NP is the number of turns on the primary coil. We know that across the secondary coil, the voltage is equal to NBA over T as well, but this time N, or NS, is the number of turns on the secondary coil. So if we were to find out the ratio from VP to VS, we can see that it's equal to NPBA over T all over NSBA over T. These all cancel, so we just get NP over NS. So we can say that VP over VS is equal to NP over NS. And because V equals IR, we can also say that this is equal to IP over IS. So we can basically control the voltage outputted by simply changing the ratio of the number of turns on each coil. So therefore, if I wanted to increase the voltage, the number of turns on the secondary coil must be greater than the number of turns on the primary coil. And if I wanted to decrease the voltage, the number of turns on the primary coil must be greater than the number of turns on the secondary coil. Now this is known as a step-up transformer, and this is known as a step-down transformer. But now the most important question, well, what is the point of all of this? So let's say from our power station we produce a current of 30 amps and a voltage of 400 volts. Now power loss is equal to I squared R. Now this is power loss. And this is how you calculate the power dissipated across a resistor or a wire like in our electricity lines. So if we want to reduce power loss, We want to transfer electricity at a lower current. Now, given that power or energy is conserved in transformers, the power before the transformer is equal to the power after. So if we use a step up transformer, and let's say we can increase the voltage from 400 volts to 400,000 volts, what that means is that the current is going to decrease to 0.03 amps. And because we've decreased the current, we've therefore massively decreased the power loss in the electricity lines. Now, when you go back to your house, 400,000 volts is way too dangerous, so you step that back down to around 230 volts RMS, and that's what goes into your homes. So, transformers are used in the power grid to increase V, hence reduce I, and therefore reduce power loss. Now, we've so far assumed transformers to be 100% efficient, but in reality they aren't. So let's look at some of the reasons as to why they're not. The first cause of transformers' inefficiencies is something called eddies current. Now we know that currents induce magnetic fields and that magnetic fields induce currents as well, because we know that a change in flux linkage induces an EMF which therefore produces a current. So, due to an induced magnetic field traveling through the soft iron core, it induces a current in the iron core. Now, this current is a waste current, it's not necessary. So, that is one way that we end up losing energy because now some power is dissipated in the iron core. So, how can we reduce eddies current? Well, the main way is by using layers in our iron core. And what you do is you basically cut the iron core into layers and then laminate or insulate between the layers. Now, this minimizes and reduces the effect of eddies currents. And obviously, what you could also do is use a lower resistance iron core. Now, some other inefficiencies in transformers can be due to the resistance of the wires in the coil. So if the coil has a resistance, more power can be dissipated in the coil. So the better way to do this is use thicker wires. And we know that from our resistivity resistance equation, thicker wires means that we have lower resistance. Now another one is that the iron core can get hot. So in order to decrease this, we can add ceramics to the iron core. So if you add a mixture of ceramics to the iron core, we can effectively reduce the amount of heat that is produced in it. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.